he's a super nice guy. So we sent Mark to go sit on the guy's doorstep and not leave until he until he agreed to at least negotiate with us or something. He talked to us, and then we ended up buying the trademark for $75,000.
Good deal.
Yeah.
Was he the one who owned the domain too?
No, that was a whole different nightmare. The domain guy, that took us 10 years to buy that Tesla.com domain. Man, and he is, I think, still like a networking engineer at Juniper. So, yeah, and that cost us like $10 million.
Yeah, that was
crazy.
like the guy just held out.
Was he just sitting on the domain, or was he using it for something?
It was impossible to. No, he wasn't using it for anything.
Just holding the name. It's like Twitter handle Falcon Heavy isn't being used. We're fighting for that one.
Yeah, so man, took us ages to buy the Tesla.com domain. But we were gonna have to change the name to be something else, and actually, the lead candidate was Faraday as the name, because Faraday invented the electric motor, and then Tesla perfected the electric motor with the AC induction motor. So if we couldn't do Tesla, we would do Faraday, and then ironically, a competitor was later created called Faraday.
Faraday, yes, a startup.
Yeah,
from China, right?
Yeah. So.
Did you guys have a Faraday logo or anything? Were you that far down the
No.
track?
We didn't really even have a Tesla logo until later, because there was nothing to sell or anything. So, but in the end, the Tesla logo and the Tesla font was done by me working with basically a little firm. That's why the Tesla and SpaceX. There's some similarities between the fonts, and that's because it was done by the same people. Yeah, I spent a lot of time on the Tesla and SpaceX fonts. Get the little things.
That's cool.
You want to eat now?
Yeah, sure.
Excellent.
I think it's all in the kitchen.
All right.
Awesome.
It would be much easier if the world was flat, or if you're in a flat situation. As soon as things are not flat, and you've got the world is like, it has undulations and curves, and then the car can be at any kind of angle, and then if you accelerate or brake, it's actually going to tip a little bit.
Yeah,
you've got sort of pitch and yaw compensation. That's where it gets really tricky.
Yeah, I mean, they're doing just amazing work. It literally just blows my mind every time. Like, there's an update. Like, you think it's like, wow, I can't believe it's this good, and then it just gets better.
Like the big one was the faster lane changes. Like as you push the turn signals, like immediately. It's really awesome.
That's so satisfying.
Yeah,
And,
love that.
I was kind of just like before. I was like, okay, it's not that good, but it feels good because like I can't believe a computer's doing this. Then we got the faster ones, and I was like, oh my god, it was so bad before. Like, you know?
Yeah.
I mean, it'll be able to just do crazy maneuvers, like a high-speed chase, technically, because it's you don't always want to bias the thing to be conservative in the actions that it takes.
Yeah.
But there's quite a significant foundational rewrite in the Tesla Autopilot system that's almost complete. As
Really?
well, yeah.
And what part of the system? Like perception, like planning, or just like?
It's instead of having planning, perception, image recognition all be separate, they're being combined. So yeah.
I don't even understand what that means.
Effectively, like the sort of neural net is absorbing more and more of the problem.
Right.
Beyond simply if you see an image, is this a car or not, or what, you know? it's kind of what do you do from that? 3D labeling is the next big thing, where the car can go through a scene with 8 cameras and kind of paint paint a path, and then you can label the path in 3D. This is probably 2 or 3 order of magnitude improvement in labeling efficiency and labeling accuracy. 2 or 3 orders of improvement in labeling efficiency and significant improvement in labeling accuracy, as opposed to having to label individual frames from 8 cameras at 36 frames a second. You just drive through the scene, rebuild that scene as a 3D thing with. It's like there might be 1,000 frames that were used to create that scene, and then you can label them all at once.
Is that related to the dojo thing you mentioned at the autonomy day?
No, Dojo is for learning, for training the neural net. That's like when you're trying to build the neural net that you ship into the car, Dojo speeds that up by hardware accelerating it.
Yeah, exactly.
Are you guys, is that up and running yet, or?
No, it might be. We might have the first one at the end of this year. But next year, I think it's very likely next year, maybe this year. But it's essentially meant to absorb massive amounts of video input, and then train against vast amounts of data, so that it can be used in the inference engine in the car. It's just like a human, really. It's like how long does it take you to learn a subject versus do a subject? It's like hard to learn, say, calculus. But once you learned it, then you can, integrate something fast or something. It's like, it's really the same basic thing.
Yeah, I mean, that'll just really tighten the feedback loop. Like, at some point, it just gets impossible to catch you guys. And, like, the rest of the people haven't even really, like, started, the rest of the auto industry. And, like, the feedback loop is just getting so tight with autopilot now. It's just, like, makes it a lot easier.
I think it will... They will catch up eventually. Or at least they will catch up to where Tesla is now. I don't know. I mean, things like for example, we're talking about maps and directions, and how today computer-based navigation is considered trivial. But back in '95, it was not trivial.
Right. Yeah.
It was considered very hard, and the compute power you had was tiny. So the code had to be super tight. Couldn't have fluffy code if you're, trying to execute something on like a 386, like very, very puny amount of memory and compute. So, so now but now maps and directions are easy. I think at some point in the future, it might be a decade or something, then autonomy will seem easy.
Yeah. I mean, it'll obviously be commoditized in the long term.
Yes. It will seem easy in 10 years. But there will be a long stretch there where there'll be vast differences between cars. Well, and I have the auto industry is used to slow rates of improvement. So, there's still not really a car yet that matches the original Model S. Maybe you could argue like Taycan
2012.
maybe.
Yeah.
If you look at like the EPA ratings, it literally is just all below.
Yeah. So that was 2012, and it's 2020. Mm-hmm. So it's still like pretty hard to get a car. Let's say there's not a car available at the price of the Model S that has the capabilities of the Model S of 2012.
It's kind of exactly what you were talking about with the Elise, where you're like, oh, we'll just put a battery in the Elise, and that kind of showed you like, okay, we really need a ground-up electric design. Yeah. And the rest of the industry hasn't done that.
The sort of founding principles of Tesla were basically completely wrong. So the premise going in is like, it's not going to be that hard. We'll just take the Lotus Elise, it's a nice lightweight car, and we'll take AC Propulsion's drive unit technology, and we'll put them together, and we'll have an electric car, and it'll be great. this sounds pretty easy.
Yeah.
Except the AC propulsion technology could not be industrialized. Like it was like basically handcrafted electronics with an analog motor controller.
Yeah.
And so depending if there was hot or cold, your car would respond differently or not at all. And the motors were hand wound. It was just like it was like impossible. You cannot scale this technology. You could have like finicky, individually made, super expensive prototypes, but we ended up using none of the AC propulsion technology. So, it's something that looks cool and works well at an individual prototype level does not necessarily scale. And then like I said, it was like maybe 7% of the parts of the original Roadster were in common with the Lotus Elise. It would have been way easier if we started from a blank slate. It would have been a better car. But I think like the real test of any given startup is how well does it respond to adversity and adapt and just figure it out. Like most things are just, when they start out, they don't make a lot of sense. But then as long as you adapt quickly, then you can make the company work. If you say like sort of Confinity, doing Palm Pilot tokens with an infrared port made no sense, but they adapted quickly to online payments. That was key. At X.com, was originally going to bite off way more than it could chew by trying to do all the banking services, and that also focused on payments. It's like, if we do all these banking things, we're going to need a banking license. The banking license is going to slow us down. We're just focused on payments, so we can just get a payment, license from the state, and it's just like $50 or something, and you can be a money transmitter, literally. And so you just got to adapt quickly.
You kind of need to be naive, though. If you had known as much about manufacturing, you might not have done it.
Yeah. It would have been difficult to. I guess if you know the outcome's going to be good in the end, sure. It sort of depends on how much foreknowledge do you have about it. Manufacturing is insanely difficult. It's underappreciated in its difficulty.
Yeah, no, that's totally true.
Yeah. Even making the Roadster, which we only like peak made about 600 Roadsters in a year, but call it like 10 a week or something like that. 10 or 12 a week. So, if 2 got made in a day, that was a big day. And Tesla's making over 1,000 cars a day now.
What I find amazing is from start to finish, a car is made in 48 hours.
Yeah, depending on what counts, start to finish.
Yeah, it depends. But you can see the rolled aluminum in one section of the factory, and you can see the cars coming out the other end, and it really is astounding. And
Yeah.
cars have been built for a long time, but this is just astounding. It's still, when you don't appreciate when you're driving a car how much goes into the level of detail, the 10,000 parts that come together, the shaping of everything.
10,000 unique parts.
Unique parts.
Wow.
But the pack alone is several thousand cells.
And it all comes together with people that are skilled, but skills are changing as things become a little bit. There's more autonomy, but it's not autonomy is not perfect. So you do need to have a lot of people there, and these cars have to be perfect. I mean, it's just
Yeah, given how much complexity there is in a car, it's remarkable that they cost as little as they do. There's so much that's in a car.
So what sort of processes did you remove, like, first principles type approach from the Elise to like the Model S? Like, was it a massive jump there?
Yeah, I mean, it's gigantic.
Yeah.
Tesla had never made a car, made a full car before. Lotus made the non-powertrain portion of the Roadster, and then Tesla built the battery pack, motor, power electronics, charger, and then put it all together at the end. And the final assembly was actually at an old Ford dealership in Menlo Park. That was, You can see some of the stuff in Revenge of the Electric Car.
Yeah, I've seen
Great
both.
movie.
Yeah, it's great.
It just gives you crazy perspective to look back on it.
Crazy.
We need a third one.
Yeah. I mean, the idea of having a car assembly tiny plant in Menlo Park of all places. And that was just because we managed to sublease the Ford dealership closed down, and we managed to get it like this deal from Stanford, because the Stanford was going to redevelop it, and we figured they'd probably take way longer than they expected to redevelop it. So we said, well, you're not bringing it to anyone. Like, can we pay you like 50 cents a square foot, and you can kick us out whenever you want? And it was this actually huge dealership, and it had enough room to do final assembly of the cars. So we just did final assembly of the cars there.
Oh, amazing.
Yeah, and one of the most absurd places to build cars on Earth is Menlo
So
Park.
no test track or anything, just the road outside or something.
Yeah. Well, in fact, we'd actually, the early roasters were very unreliable, so we'd generally put about 50 miles of just normal driving.
Oh,
so just
wow.
drive around the Bay Area with somebody following you.
You must have got some crazy looks from people, right? It's like, what is that?
Yeah, but we'd put 50 miles in each one of those cars because they just have a lot of things that would break down in the first 50 miles. And then battery production was in San Carlos. Yeah, so man, there's just a lot of detail on that and all that. But going from the Roadster to Model S was a massive leap, because the Model S is quite a sophisticated sedan where Tesla built the whole thing as opposed to just building the powertrain, and so competing against like Mercedes, BMW, Audi type thing. So that was a massive leap of difficulty. We did get the NUMMI plant, but really that just meant we got $8.
Yeah.
Because they stripped the plant of all the good equipment. The only equipment that Toyota and GM left behind was the stuff that they could not use anywhere else.
Wow.
So they only left the most
Trash.
junky, broken pieces of equipment behind. We managed to use some of it, but yeah, in the paint shop. I mean, some of the things were literally not even worth the scrap value. so it was like not worth it to call the scrap metal dealer.
What'd you do with it then?
We made a lot of those things work.
Oh, you did?
Yeah, plastic injection molding machines, and we just made them work.
Wow.
And the paint robots, we mostly made those work. The assembly, the body production line had to be made new because there was just nothing. So we made the body production line for Model S was created from scratch. And it worked out, but it was very difficult. It was also in the beginning, the top suppliers would not work with us, or we would get like their D team, because like who wants, if they got all these customers, like they got the big car companies, they got like Toyota, or they got Audi, BMW, Ford as customers, and a startup. Now you're in the supplier's position. Which team are you going to assign to the startup that everyone says is going bankrupt? You're going to assign the interns and rejects. Okay, it's not going to be your top team.
We have the same thing with our
Your top
Twitter.
team's going to go to like Toyota. Your big customers, the top team. So we would get the worst team usually at the supplier company if the supplier would even work with us.
You think that influenced you to vertically integrate more?
No, it's vertically integrate or die.
Makes sense.
Yeah. We tried outsourcing. The battery production originally was going to be made at this place that made, I think, barbecue grills in Thailand.
I read this story.
Yeah, and I was like, man, they have no idea how to make a battery. And I was like, this is crazy. We're moving it to back to our headquarters in San Carlos. And we're just going to make it here. Because once there's a massive amount of work going from a prototype to production, and so you need a fast feedback loop with engineering, and if that feedback loop is all the way out in Thailand, it's just no way. It's not like if you have an existing production line that you already know how to make it in volume, that you can move, but you cannot create a production line that never existed that's super far away from where the engineers are. it's a recipe for disaster. And also the cells were coming from Japan, so they go from Japan, they go to Thailand, they go through customs, they'd be waiting, and then they'd be going to a battery pack. Then that battery pack would be sent to England. Then Lotus. These are all things that got changed. But the supply chain, like let's say there'd been a problem with the cells, you'd only if the supply chain was so long that you'd only find out that it didn't work 5 months later.
Yikes.
Yeah, and then you have 5 months of scrap inventory. So this is a recipe for a disaster. So that got moved to San Carlos. Cells shipped directly to San Carlos. Put it in a module. Figure out why the module's not working. Fix it. Put it into a pack. Like the original reason why the Roadster battery pack had, I think it was like 16 sort of blades, was if one of them didn't work, you could pull it out and put another one in. Because that happened. So you don't really need modules in my view. You should just go from cells to pack at this point. But it was a very difficult thing going from Roadster to Model S.
The fact that like the Model 3 still has modules is kind of vestigial.
It's vestigial, yeah. Because the modules in the Model 3 are not actually interchangeable, so there's no point in having modules really. We should just have a pack.
Was that done to just save cost then, or some other reason?
It started off because it's not a sensible reason. The reason that there were cells, modules, and pack goes back to the early Roadster days, where we'd make a module. That module would have problems, and so then you could swap out a module. It's like a server rack. The idea was like, if you have a bunch of servers in a server room and one of the servers flakes out, you can just pull it out and put another one in. So without having to replace, so you could replace a small fraction of the pack instead of the whole pack. Then that concept just carried forward into Model S, X, and 3, but without the original logic no longer exists because the modules are not interchangeable.
Yeah.
You can't just swap out a module. But these things just have a lot of inertia. So we really want to move to no such thing as a module. There's just cells and pack. Yeah.
Yeah, because initially they had the battery swap facility right at Harris Range.
Yes.
And then the Model 3, I don't think it had that capability that you could actually swap the whole pack out quickly, right? Or I don't know if that was...
It does not.
Yeah, right.
S and X still have the ability to do a fast pack swap.
Right.
But things essentially evolved in the same direction that phones evolved. For a long time, phones had swappable battery packs, and now basically almost nobody makes a phone with a swappable battery pack.
Definitely.
As soon as the range gets past a certain point, then
I agree.
Yeah, it doesn't make sense. But this was far from clear at the time of designing the Model S. So we went to a lot of trouble to make the S and X pack capable of a fast swap with quick disconnects and bolts coming in only from the bottom and that kind of thing. And then we did that demo where we just swapped out 2 packs faster than you could pull a gas tank.
That's amazing.
It's kind of ridiculous to me, like taking the battery out of your car just in, Harris Ranch, and they put a new battery in and you come back. It was kind of like, it's good that supercharging got a lot better.
Yeah, it was just way better to increase the range of the pack and have faster charging. But this debate, which seems obvious in retrospect, was not obvious at the time.
Definitely.
Back then, I think at least a lot of phones had swappable packs. Because remember, this would have been designed in, we had the first prototype out in 2010 for the Model S. So back in 2010, let's say the thought process going into this in 2009 would have been, at a time when, I don't know, maybe most phones had swappable packs or something like that, The iPhone was like 2007 or something, iPhone 1. So then it didn't make sense. But companies have a lot of momentum. So the S and X pack is still a swappable pack.
Yeah.
It was like too much trouble to change the design. And Model 3 still has modules, even though it shouldn't have modules. And to some degree, like what you'll see in any given product is that the errors in the structure of an organization will manifest themselves in the product. So, that's where, we have a module team, so we have modules. Like, wait a second, just combine the module team with the pack team, and then there will be modules. So generally, the errors in the organization manifest themselves in the product. You can see where the organizational boundaries are, and then you'll often get like a box in a box. It's like, wait, why does this thing have 2 boxes? Well, because this team wanted to have an enclosure, and this team wanted to have an enclosure, and so they have an enclosure on an enclosure. This is still the case with it's like, what a silly thing, but that's actually the case with the Model 3. Model 3 battery pack has a top enclosure, and the car also has an underbody.
Yep.
What's the point of that? That doesn't make any sense. Because the pack team wanted to have an enclosed battery pack, and the body team wanted to have an enclosed body. Yeah, it makes sense. But you don't need 2.
Oh.
So, yeah.
Awesome.
So this is all this, and putting the top cover on the battery pack is a big pain in the neck. So it adds mass and cost and stuff. So that should definitely go away in the future. Lots of brackets on brackets, that kind of thing.
So you survived the production hell of the Model 3, which was pretty intense. I mean,
that was like stupendously difficult. And I mean, I think it's sort of Tesla. I don't know if this is accurate or not, but I think it might be accurate. Is the first car company to reach volume production, I think in 80 or 90 years or something like that in the US.
That's wow.
Yeah,
And it's a harder time to do it, for sure.
Yeah. The complexity of like what people the regulatory requirements and the minimum expectations for a car at this point are dramatically more than they were 80 or 90 years ago.
And the place you chose to do it, too.
Yeah. So it was a super difficult one. I mean, there's lots of car company startups, but doing the prototype is the easy part. Building the production system is 100 times harder.
yeah.
So, I mean, that's where you see the things fail. Like, there've been, over the course of the last century, probably thousands of car company startups, most of which people have never heard about. Occasionally they'll hear about something like a DeLorean or a Tucker. Most of them, there's not even a footnote. And it's because of the difficulty of production. And here's a real important point that is not well appreciated. This is a point that should be advanced by short sellers, but I've not seen it. I've not seen it articulated, but it should be. The incumbent car companies make most of their money from selling spare parts to their existing fleet at high margins, and they'll sell the new cars either at de facto zero margin or even at a loss. It's kind of like printers and cartridges or razors and blades. You sell the razor at a loss, sell the razor at a profit, sell a printer at a loss, sell a cartridge at a profit, or video game consoles. The actual cost of, say, an Xbox is $600, but you can buy it for $300 or $400 because they make it up in the games that are bought.
Yeah.
So so if you're a new company, you do not have a fleet. So you have no fleet with which to subsidize the sale of your new cars. This is the primary reason there has not been a successful car company startup in the United States. This is the primary reason. Because the incumbent car companies have 80% of their fleet outside of warranty or something like that. Maybe it's 70%, but approximately. Like if a car lasts for, say, 20 years or something like that, and the warranty is for 4 years, then it's 80% out of warranty. So even if they stopped selling new cars, they would still, their profit would increase. So
According to Edmunds, dealerships make 20% of their revenue, but 50% of their profits on service.
Yeah, exactly. So, and the car companies themselves will often make more than 100% of their profit on selling spare parts.
Wow.
Yeah. So if the point at which they're making, say, 110% of the profit from selling spare parts, it means that they're actually selling the new cars at a loss. So this is the very difficult thing to overcome. In order to overcome it, a car has to be significantly more compelling than other vehicles, such that people are willing to pay a premium, and that you can actually be positive cash flow, aspirationally profitable, selling new cars, not simply selling spare parts to the fleet. So, I mean, for Tesla's fleet is probably 10% of Tesla's fleet, or something less than 20% is out of warranty, whereas 80% of the other car makers is out of warranty. So this makes it very difficult. Also, electric cars need much less servicing, so that's another difficult thing. So this is the main. This should be the main argument advanced, I think, for why a new car company cannot be successful. The main one. And so, yeah, then like I said, in order for that car company to have any chance, it must be compelling enough that people will pay a premium. Otherwise, there's no chance. And I think there's actually, in order for a car company to be successful, it has to succeed on two fundamental technology discontinuities. One being electrification, and the other one being autonomy. I think not even pure electrification by itself is not enough. Mm-hmm. So you can but like since the moving production line, there have been two major technology step changes, being electrification and autonomy, and the combination of those two is that's the only opening for a new car company to make it.
Yeah, it makes sense. I mean, without autonomy, you'd probably have to wait for EVs to reach price parity. With autonomy, you can drive many more miles and bridge that gap easier.
And it's like, well, Tesla's moat in some ways, or not moat, I guess, but like Tesla's advantage in many ways is bigger because like these are two such different technologies that are happening at once that you've been working on while nobody else has. So it's like that much harder to replicate now that it's been accomplished almost.
It's very hard for any new car company to enter the market. They have to make a very compelling product, meaning they have to have some significant technology advancements in the electric drivetrain and the battery pack, and just generally with the car itself. And then the autonomy has to be very compelling. Autonomy in and of itself is enormous. So both of those things a company must be successful in doing, or they will end up in the cemetery. So that's the real challenge of it. Yeah.
Well, even with like the software updates, I mean, that's something that no other manufacturer can really even get right. They can't do it over the air. You have to take your car into, because it doesn't work, right? So that's a core component of providing updates. Instead of getting your revenue now from the dealership and spare parts and stuff, you can actually send software as a service. We actually did a whole podcast on this.
Well, our goal is to minimize service costs.
Yeah.
Whereas the other car companies, I wouldn't say the goal is to maximize service costs, but it's certainly not to minimize it.
Well, car companies also have two different businesses. There's the dealerships where their business is actually just service, and I don't think it's anyone's surprise that people don't like going to their dealer. I mean, it's like it's because their incentives are actually not aligned with the customer's incentives. Their goal is to bring you back as often as possible.
Yeah, the dealerships' incentives also misaligned with the car companies during the warranty period, because the car company has to pay for the warranty, the service during warranty. So it's that they have a conflict of economic conflict of interests. The car companies cover the warranty costs, but the dealership makes profit on the servicing. So they want to maximize servicing even during the warranty period.
Yeah, it's almost like the economic factors you just mentioned have created like complacency where there is no innovation because, nobody can just start a car company.
Yeah.
Right?
I mean, it's like Schumpeter's creative destruction. There's like innovation tends to come from new entrants to an industry. So if an industry has formed an oligopoly or something like that, then the forcing function is weak for innovation because innovation tends to come from new entrants. Yeah, this is the problem with rockets. There's not a lot of new entrants, so innovation forcing function is weak.
But it's encouraging to see a rocket booster land.
Yeah.
And everyone is all like, wow, we can innovate maybe.
Yeah, it's actually been surprising how little innovation there's been and despite SpaceX showing reusable rockets, landing and reflying these rockets many times, they're like, come on, just copy it or something.
Same with Tesla. I mean,
Yeah.
tech works. Just do the same thing.
Didn't like Chinese space companies started putting grid fins on their rockets?
I think there's some Chinese rockets that have launched with grid fins. Well, you can really use any kind of fin. Grid fins just are more predictable across a wide range of speeds. So from hypersonic through, supersonic, transonic, subsonic, it's quite easy to predict the behavior of a grid fin, and the center of pressure of a grid fin doesn't change that much. Whereas if you have a fin like a wing-looking thing, that you'll see quite a big change in where the center of pressure is across a wide Mach regime. Yeah, either one would work. The shuttle didn't have grid fins.
What do you think about Rocket Lab's approach of trying to use a helicopter to recover the first stage?
I think that's going to be harder than it seems.
Yeah, I think so.
But their booster is quite small. So the issue with helicopters is you run into a max load problem. Like the lifting capability of helicopters is not that great, and that lifting capability drops with altitude. And then the range of a helicopter is also not that great. So then you end up having to have the helicopter on a ship, and then if in heavy weather conditions you can't take off. So that you have to be your weather constraints at the launch point and the catch point are end up limiting your launch availability. And then you got to. It's dangerous. You've got somebody in a helicopter with a pilot trying to catch this thing coming out of the sky.
Yeah.
It
Doesn't sound too sane.
there's certainly the potential for something to go wrong. Whereas if you have a drone ship, there's if it smashes into the drone ship, it's not a big deal. If it smashes into a helicopter, that's a big deal.
Sure.
Yeah. So. Overall, I've been, that said, I've been pretty impressed with Rocket Lab, and they're making a go of it, and they're going to do reusability, which is important. It's fundamental.
Do you guys still see yourself doing that city to city travel in 30 minutes one day?
That would be awesome.
I want to do more Starship.
Yeah, I think that for sure can be done. Yeah, for sure can be done. It is loud. It's really a noise is the biggest concern there. Both taking off and landing. When it comes in for landing, that sonic boom is loud. It's like there's actually two sonic booms. So it sounds like somebody just discharged a double barrel shotgun in your backyard. So. It's not like it's breaking windows or anything, but it's like it'd be pretty annoying if it's happening on a regular basis. That's basically what it amounts to. So then you have to do it offshore, So I think we'll do, but can it be done? Definitely. And it's the fastest way to get anywhere based on known physics. So, and I think the economics can be made to work as well, so that it would be competitive with international air travel.
It'd be exciting.
Wow. That's
Yeah,
you?
yeah.
Wow. I can't wait for that.